We are here to talk about Target's application platform. Just want to know quickly, like how many of you know about Target Corporation? It's like yeah, this is our team over here. You folks from retail, how many from the retail industry? Good. Okay, great. So little bit about Target, and then we will kind of move forward, right? So we have about 1,800 plus stores in US, in all 50 states. We have about 350,000 team members. Our headquarters is in Minneapolis. We do have locations in California and in Bangalore in India. About 30 million guests visit our stores each week. So our e-commerce website receives a significant amount of traffic every month. It's kind of like the fourth most visited retail website in the United States. But our website is just one part of our digital strategy. Our flagship mobile app allows you to easily purchase products from your mobile phone. Convenient features like map with locations of the product that you're looking for, and wallet, which allows you to combine discounts such as Cartwheel, and then kind of combine it with Red Card discount and quickly check out. So we also have features like Ship and Drive Up. And these do provide convenient services for you to kind of purchase stuff right out of your car or get stuff delivered straight to your home. Another interesting thing that we do is Drive Up, which gives you a way to order items online, and then we kind of notify you once your items are ready to be picked up. You let us know what car you're driving, the color of your car. You drive to the store. We use geofencing. Somebody will walk out, scan your app, put the items in your car, and you can move. So that's kind of like a great service that we provide. But that's the marketing side of it, right? So we are here to talk about tech. I didn't introduce myself, but Jim and I are talking here today. I'll let Jim introduce himself, and we'll go forward.
My name is Jim Beyers. I run platform services inside of cloud and compute, inside of infrastructure and operations at Target. Our team essentially is writing the software that's powering TAP, Target Application Platform, that we're here to talk to you about. Jay?
I work with Jim. So my team is responsible for the compute services, the underlying, the VMs and the Kubernetes clusters that run in our data centers, in stores, and in Google Cloud. The talk that we are going to give today is the body of work that our teams have done over the last year or so. So what we plan to do here is kind of like share our journey that led us to build an application development platform. So I'll kind of share the landscape we had prior to building the platform at Target, the problem we are trying to solve, and then we will talk a bit about some of the principles that formed the basis of building this application platform. And then we'll share a little bit about the inner workings of the platform, and we'll give you a walkthrough of how a developer interacts with the platform. And we will finish off kind of sharing with you folks what's the current status of it, and our future plans, so to speak. So how we got here. I think many of you who have been in the industry for a while can probably relate to this. You know, how it goes about is application development teams need to build and deploy like an app. They reach out generally to infrastructure teams. They make a specific request. The infra teams place an order, wait for the servers to arrive. We rack them and turn it over to the development teams, and they kind of use it. Simple, right? I mean, but it's kind of complex, right? At the same time. We even did like service enable the access to the compute, right? But it only provided, again, like incremental benefit. So what are kind of the problems that we faced just by providing access to compute directly? Infrastructure change fatigue, right? The teams who got their pet servers ended up spending a lot of time like patching. Infra teams like us ended up spending a lot of time tracking abandoned servers, unused servers, doing like server upgrades. For service-enabled platforms like OpenStack, Kubernetes, we still ended up like asking teams to do the work, right? To make changes to support the platform, to do like upgrades, migrations, things like that. So development teams still ended up with like a significant amount of infrastructure work in their backlog, basically. And this has been like kind of disruptive for them. So that's one part. Now there is the other part from a developer standpoint, right? So the developer kind of faced like very disparate experiences, right? They need to deploy applications to our data centers, to our stores, our distribution centers, to Google Cloud. Deployment to OpenStack in our data centers is very different than how do we deploy to Google Cloud or to our edge locations that run Kubernetes. These are all different. So the development team ended up using like different deployment tools. And they have to so build them. They have to maintain these tool chains. And this is like work for the development teams. Application development teams like that support our distributed, that work with our distributed platforms like stores, sometimes end up spending like even 70% of their development time like in deploying workloads to these distributed edge locations. Again, plus on top of this, there is no standards in terms of like how teams can implement logging, monitoring, basic operational stuff. Sometimes there are too many options, sometimes there are too less options. So it's kind of hard for developers to figure out what's the right pattern to use. So we started off by removing technical debt, right? So what's technical debt? We declare it as anything, right? It can be obsolete hardware, unused, underused applications, anything that prevents you basically from building capacity in a modern technology. So we started kind of working towards like removing technical debt. So we literally like removed physical hardware from our data centers, which are legacy. We removed thousands of like equipments from our stores, old PDAs, servers, and just we retired hundreds of applications, right? So just to help teams get rid of these legacy backlogs so that they can focus on building new. And how does it help, right? So one, it helps by us not having to pay millions of dollars in terms of vendor licensing cost. And this also frees up application development teams to start building modern applications. And we started with that. And we gave them direct access to our service-enabled compute platforms. And that doesn't help. They will basically end up with like a whole lot more work when the lifecycle of these compute services come up. And this is where TAP comes into play. So Jim will talk about how we approach that problem.
Thanks, Jay. So Jay sort of outlined sort of the history as to why we decided we needed to build TAP. I think you probably all can relate pretty closely with a lot of the things he was talking about. So before we decided what or how to do what we were going to do, we decided sort of the why, if that makes sense. And honestly, even before we started with the why, we just started with the who. So a peer of Jay and ours, a guy by the name of Dan Woods, came up with this concept of someone that he referred to as the midnight developer. And the midnight developer is someone who's starting from nothing. She may have never interacted with the platform before. Maybe she started today. And she's trying to get something together for her demo the next day. If she can't build a fully featured demo without having to have like a meeting or a ServiceNow request or whatever your ticketing platform is, like we've failed as a team. And disclaimer, don't work at midnight, like have a life, right? So the 6 principles that we came up with are as follows. So the first one's self-service. Like I mentioned, it's 0 meetings up and running. Empower the teams to get their project off the ground without needing to interface with any of the platform teams. No meetings, basically. Common patterns of usability. So teams will interact with the platform offerings in a common way. So when Jay was talking about disparate experiences, like if you have to write chef scripts to deploy things to stores and you're using Spinnaker to deploy to GCP, that's, we're not having a common experience. Discoverability, teams should be able to quickly and easily ascertain what the capabilities are that are available to them on the platform. So essentially similar to what the no meetings, it should be like, not no docs, but it should be fairly intuitive to open up the page, look at what you need to do. I need a load balancer, click a button. Not read for 30 minutes or try and find some tribal knowledge. No searching wiki pages. Availability, it's got to be up all the time. We're not going to have maintenance windows. And dev is prod. Everything's an application. Tap uses Tap. We bootstrap Tap with itself. That's a big, broad conversation. If you'd like to hear more about it, I'll have to talk to you about it after. And then strong opinions loosely held. So that means that the decisions that we made today for the underlying implementations of the componentry of the platform may not be the appropriate decisions for the underlying componentry of the platform tomorrow. So we need to build the platform in such a way that we can swap things in and out interchangeably. And we've done that quite a bit in the last year. So what did we build? We built Tap. You already know that. It's the target application platform. Tap is this consistent experience like we outlined in the principles. What Tap is not is GitHub Enterprise. It is not Artifactory. It is not Spinnaker. It is not Kubernetes. It is not OpenStack. It's none of these things. It's essentially the overlying platform that abstracts you away from these independent tools so that you've got a consistent experience across all of them. It's like the glue code that we wrote to do this, right? And we did this by starting by saying, like, we're going to look at what's the fundamental underlying sort of runtime components that we need to have. And obviously, one of those is compute. So Kubernetes is a fantastic container scheduler. It's also a great platform, but it's a fantastic container scheduler. So we started with the idea of, like, let's figure out how we can leverage the scheduling aspects of Kubernetes, but open up so that we can use other areas, other pieces of the runtime components other than Kubernetes. So in other words, what I'm saying is we're not just dumping everything into Kubernetes. So what we did was we wrote shim layers in front of each deployment of Kubernetes so that we're deploying through the shim. So what that means specifically is we decided to use the Kubernetes deployment spec for every deployment when we deploy to a compute provider. And what that allows us to do is to have multiple instances of Kubernetes that could be potentially different versions. They can be running on obviously different compute. And ultimately, that's all abstracted away from the users. We recently ran into the Kubernetes 1.6 vulnerability I'm sure everybody is used to. There were breaking changes in the contract between 1.6 and whatever we went to, 1.14. That was work for people, and that goes back to what Jay was saying before about how we don't want them to have to worry about these kinds of things. The other really cool thing that this allows us to do is to present other compute providers with the same deployment spec. So you write your app once, and you can deploy it to Kubernetes. You can deploy it. We started with OpenStack for our VM provider, which solved a different problem. Whereas before, we ran into some issues with large installations of compute services providers like OpenStack with doing things like upgrades, infrastructure upgrades. Now we can do our favorite tagline, more of them smaller, so that if we want to take out some compute provider for maintenance or something like that, all we have to do is have teams redeploy. We can take things offline. Nobody even needs to know, which is pretty sweet. And so we can do the same thing with other compute providers, rinse, repeat. How do we deploy to those compute providers? We wrote what we call this platform intelligent engine, or PI, that implements the Kubernetes deployment spec also, and then makes an intelligent placement decision to one of those compute providers. Now, to be honest, the actual intelligence of the platform intelligence engine right now is not particularly intelligent. We take in some of the different specs, like we have these other concepts I'll touch on in a little bit, like pool type, or if you're a compliant workload. or if you want to be a VM or a container runtime, and then we make a decision. And some of the ways that we do that right now is just by weighting or giving preference to specific, what we call pie slices, that's a compute provider, to say, hey, deploy here. A really crazy and great story is Jay's team wrote something that we call SGDM. It stands for Server Group Deployment Manager, and all it does is it's a VM runtime, dead simple, runs VMs really, really well, and we moved almost all of our non-compliant workloads that were running on OpenStack over to SGDM, and none of our users even knew, which is pretty rad. So that's that. So that covers the compute provider aspects. The other areas, obviously, of the platform is this is not just running CPU cycles, right? We've got things like config and secrets, load balancing, log metrics, and potentially things like an API layer or API proxy. Today, we started with console for config. We've taken out pieces of console as we've, over the course of our journey, and replaced them with some homegrown pieces, et cetera. And our users didn't know, which was great. We use Vault for secrets. We're using Fabio for load balancing. When you deploy your instance, basically it auto-registers with the load balancer, which is pretty sweet. And this goes back to sort of that principle of the fact that we might make decisions today that tomorrow we might want to change. So I'm going to do a walkthrough, but I want to cover some basic sort of core concepts and terminology that's going to be somewhat probably important. I'll try and go over this quickly because maybe it's going to be rudimentary for one another. Or for people, sorry. So an application is essentially a project. You start your application inside of the UI or through the API. Everything in Tap is API first. So you don't ever have to interact with the API if you don't want to. You can use the CLI that we also have. It's pretty great. Application is essentially the container for your code. Inside of an application, there's the concept of a cluster. An application can have many clusters. Clusters belong to an environment. We only have two. There's dev and prod. Clusters are the logical organization of infrastructure. You can have one or many deployments, like I said, and so you deploy to a cluster. Instances and server groups. So your Docker container or your VM is an instance. You can have one to many of them inside of a server group. That's your basically unit of deployment. One of the things that we do require inside of every application is that every instance has an instance health check. So you can run any Docker container you want on the platform, but it has to have a health check. And the reason that we implemented that is so that if your application is up and healthy, as determined by you, then it will register with a load balancer and start taking traffic. Currently, we only take HTTP traffic, but that's in flight. Pretty quick for us to be able to do TCP also. And then there's this concept of stacks. So as I said before, applications are globally namespaced. Stacks are also globally namespaced, such that you can have so Red Sky is an application at Target. You can have a Red Sky UAT. You can have a Red Sky performance. You can have a Red Sky if you want to, all in production. And so that allows you to wire different deployments of your application together so that you don't get interference if that's what you want, say specifically for performance. So that covers the sort of high-level concepts I just wanted to say because you're going to see some of those in the UIs. We weren't brave enough to actually do a demo, but I have video screenshots of the app here. And I'd be happy to show anybody this later if they're interested and I can get on VPN. So, all right, bear with me because taking video screenshots of stuff is a little bit wonky. Is this it? OK, so, oh shoot, so I already went too fast. So this shows here that basically my screen as a user of Tap. It shows all the teams that I'm on inside of Tap, because you might want to be able to allow other people to deploy your application in besides just yourself. Seems reasonable, right? I'm going to walk you through what we call Quick Start. I'm going to create an app on Tap. So I'm going to click that button. I'm going to say I want to start a new project, or I could start with existing code. If you ever used a platform as a service, some of this should look familiar to you, but obviously some of it's target specific. So I'm going to choose my application name. It's my next demo, I think. Yep. And I'm just going to make sure that it's available. If it is, now this is mine. I'll come back to this, but like essentially when it gets deployed, it's mynextdemo.dev.target.com, or if I'm in prod, it's mynextdemo.prod.target.com. Hit that, you go directly to the app. Or the stack if you're using stacks. Blossom ID is essentially just like a configuration ID. It's like a metadata service at Target that allows us to do things like chargebacks, or not chargebacks, sorry, showback, so that we can show how much specific apps are costing, et cetera, or to be able to tie back to a particular line of business. And then the team, like I talked about before, if I want to give access to other people to manage my application inside of Tap, I can add them to my team. Then I'm going to add my contact email and my description, and then I'm going to say, hey, what GitHub organization do I want? And I'm going to choose me. Then I'm going to say go. And then I'm going to decide, here's the 4 things that we support so far. So Praxis is an internal Target UI React set of components. It's more or less how most front-end stuff is written in Target. So I can quick start a Praxis app. I can do a Spring Boot app. I can do a Ratpack app or a Ratpack with Groovy. About 85% of the Target apps are Spring Boot, we think. So I'm just going to do that. Also, it's the one that I know how to do. And then I get to decide between a container and a virtual machine. So like we said before, it's not specific to the actual compute provider because we want to have the capability of being able to sort of decide what's the best thing for today. So maybe today it's OpenStack, but it's not. Now it's SGDM. So we decided to do virtual machine so that we could make those decisions as we're the ones that are supporting the infrastructure. And the same thing we believe is true for containers, probably Kubernetes though. So I chose container, and it's just telling me what it's going to do now, which is going to scaffold out some code in GitHub. It's going to create my drone config, and it's going to run my build in drone. So drone's our CI tool, if you guys aren't familiar with it. And then it's going to deploy, create my cluster and deploy my code. So I forgot that I had to be signed into drone when I made this. So I signed into drone, and then it did it. So you can see here that it actually had already been working, but I wasn't signed in, so it built my code. So like I said, this is a little bit wonky. Give me a second. There we go. Sorry. All right. So after that, this is just a short screen that shows essentially that we knit the scaffolded code in GitHub. It ran my drone job, and it created the cluster. And then after that, it actually created the cluster, but I wanted to show what it's like for you to create your own. So this concept is the concept of stacks. So this goes back into like if I wanted to have different environments inside of my environment because I wanted to test out different lines of code. Here's my next demo-dev. It's available. I'm going to click continue. And then these are some of the config items that people can select from. So today we only allow to deploy to the data center. We started some work on being able to deploy it to public cloud or to GCP. And then also, obviously, as Jay mentioned, our goal is to be able to deploy workloads also to stores and to distribution centers. There we go. So pool type is something that we also allow for you to be able to sort of define if you've got constraints with respect to your runtime. So if you are a SOX application, you would choose that you wanted the SOX pool type. We have some special sort of stuff that we reserve only to certain users at Target. So like there's a group that's doing work on GPU. We created a pie slice that was able to deploy to some GPUs, and they're able to see that in here, which is pretty slick. And then there's the proprietor type, like I chose earlier. There's a container and VM runtime. And then the region at the end is we've got TTC and TTE are the 2 Target data centers. And then there's also an option to choose HA. I'll come back to that because this is essentially just like my app is running on port 8080, which is the one that the load balancer is going to hit. And then I get some choices that look very similar to Kubernetes with respect to how many millicores and how much memory I want. This is the health check I talked about. So you can implement your health check however you want, but you have to have one so that we know that your app is up and available, because we don't want the load balancer, obviously, to route traffic to garbage instances that are not working. This is just basically the config for that. This is the deployment strategy. Today we only support 2, red, black, or blue, green, depending on if you are more akin to Netflix, and then Highlander. So deploy my instance group, wait for it to be healthy, and then I'll start running traffic to it, or deploy it and then destroy the other one right away. Which I'm embarrassed to say, it took me a long time to realize why it was called Highlander. There can be only one. So server group capacity is just how many instances do I want to deploy. You can say 1. I don't think we have a limit. I know for sure that there's some people that have like 80. Actually, yeah, maybe more than that. Choose the size of the number of instances that you want and then deploy. We do have plans in the future to be able to do things with the platform intelligence engine to say like, hey, someone today might say, hey man, I'm going to get a million TPS. Well, that's generally never true. And so they might way over provision, and we could have the potential, since every app that's deployed is using the runtime connector, is automatically instrumented with logs and metrics. So we know the health of everything as long as it's running with the health check endpoint and it's using the runtime connector. So we would be able to do what I'm talking about, which is if it's taking 2 TPS and running at 0.01% CPU utilization, would scale them down in the future. So and then, like I said before, everything is API first. So you'll see here that that's essentially the JSON of what the API will look like. Next, the details. So now that I've deployed my cluster, it's up and running. I'm just going to go and check and say, hey, here's my pipeline. We're using pieces of Spinnaker onto the covers to run deployments for TAP. There's quite a bit of custom pieces that we've taken out and rewritten ourselves because they were more akin to our use case, I'll say. So essentially, that's your Spinnaker pipeline. Create the server group, disable the old one, and create the new one. Here's the UI for config and secrets. So for console for config and vault for secrets, you can enter your stuff in right here, and it'll get injected into your application, provided you've written your code correctly. And let's see, this is basically going back and being able to edit those constraints I showed you earlier if you want to do your deployment. It's not an uncommon thing for us to find customers that deploy to the container runtime and find out that they're actually very compute-intensive workloads that they decide that it's better for them to run on VMs. That's actually quite common. And oh, yeah. So inside my group of server groups, there would be, if I had more than one instance, all the individual instance. I can go directly to my instance logs, directly to my health check endpoints. So I clicked on that. That takes me to the logs specific for that runtime. Sorry, for that container. There's health checks specifically for that for that instance. And all right. So this is pretty slick. And the reason I said before about the HA, I was happy to have caught one earlier. But basically, what we see here is a sort of production view of the platform intelligence engine. So on the bottom is a list of all of the pie slices, which, if you remember, is the facade that sits in front of a compute provider. So if you can kind of infer what most of them are. The first one is a K8s provider that's running inside of our TTS data center. And we've got 1,300 instances in there. You can see that overall, of all of TAP, we've got a little over 20,000 running. I think it comes right at 20 seconds. You can actually see in the pie slice activity, that little spiral dealio, actual deployments that are going on, which is kind of cool. And right at 20 seconds, you'll see the two happen, and it's an HA deploy, one to TTC and the other one to TTCE. If we scroll down, then you'll see sort of some of those constraints like we talked about. Just about everything in here, I think, is, well, no, that's not true. Most everything is obviously gen pop, hence gen population, but you've got SOX pool type running on OpenStack. We've got gen pop running on a VM. This is that SGDM I was talking about. And there's a bunch of different pie slices in here, including, I think, I can't find it. I don't remember. I know the GPU one is in here. There's like 4 GPUs. It's not that cool. So that is Pi. And Jay's going to talk now a little bit about the status of TAP and sort of where we're at today.
Thanks, Jim.
Sure.
Can we switch over to the slides? Okay, thanks.
Oh, you just...
Yeah, that's fine. So, current status, right? This was launched last year, specifically like April 1st. It's not a joke as such. So we're exactly 1 year into building the platform and running it. And you can see the adoption curve. It's just kind of rocketed up, right? And this is real, right? It's running production workloads in Target, supporting our business. This chart is like few weeks old, and the current one, it's still the growth is like the same pace. We now have about 5,400 applications running. We have about 20,000 instances, 4 deployments per minute. That's happening. So if you think about it, the friction that we are removing from our development teams, right? They are doing like about 5,700 deployments per day, right? And without just by clicking buttons, this is like the work they don't have to do. So that's actual advantage for us. So future plans. So our vision is that TAP will be one-stop shop for all compute and data needs for our developers. So we will accomplish this by abstracting the compute and the data provider layers away from the developers, as Jim demoed it. So they no longer have to worry about which version of Kubernetes they are running on, whether they are running on Google Cloud or in our data centers. Jim also demoed and talked about Pi earlier. This component of the tab will become intelligent over time. And with that intelligence, we will be able to make automatic workload placements using tab, basically determining which is the best location to run the workload. We also have a great ability to improve efficiency of our compute platforms. We can actually understand the application's resource usage, and even if they are allocated like a higher resource than what they actually need, the platform can actually dial it down. We also have, of course, in our custom compute platform, we have much better ability to over-provision. We actually see like about 70 to 80% of physical compute utilization in our custom compute platform, which is kind of great. So our plans, Jim kind of touched on it too. Currently, our focus is on getting things running in data center. We are going to switch over to get this thing working in Google Cloud and to our edge locations in stores and distribution centers. We already have Kubernetes clusters running in our stores and distribution centers. The plan is to have this platform that we build called Unimetrics, integrate that with TAP so that developers interact with TAP. And that's the way they will deploy workloads in Target. They're not going to have any of those disparate experiences. As I mentioned earlier, we can move workloads around based on attributes like availability, response time. With TAP, we should be able to burst workload into Google Cloud if we need to. Or we can automatically move workloads to our edge if we need a better response time or availability. So basically, we see TAP as like the one-stop shop for like our developers to interact with infrastructure. So we are excited about our journey, and we believe TAP gives our developers the ability to focus on delivering new feature functions for our guests and like build productivity tools for our team members. And thanks to TAP, I believe our application developers will be able to do this in a much faster rate than any of our competitors in our industry. Thanks.
Thanks, everybody.